Good morning, welcome to Precalculus. Today we're going to be working on using the features of our calculator for regression analysis. And on your paper, I would like you to write what I didn't write on it, but I wrote it up here, is thousands. The wording from the book is proper, but these are applications in thousands. So how would you go about this one? Do these words make any sense to you at all? I think we might have seen this. You know what a regression is? Regression analysis. Justin's not as if. Robert, no. Riley, no. You Algebra 2 honor students from last year. You remember that? Karina, what this is? Elizabeth, you remember? Okay. It's faintly recessed, okay? To do a regression analysis, what you do is you go to Stat, Edit. And Stat Edit is where you put your data for your lists. I'm going to clear out this list by going to Clear down arrow. Then clear down arrow. You remember that at all?
Yeah, a little. Yeah.
A little bit?
Yeah.
Okay, what we do is you put the left column. Now, what they've done is they set this up, said let 1980 stand, 0 stand. So I'm going to put 0 here, and 10, 15, and so on, down to 23 for these. Does that make sense? So we go to our calculator. So we put 0, 10, and I'm just kind of looking at my sheet here. The next one here is 1991, right? Let me see, I would see if I can read it here. No, 95, that's 15, right? So that's going to be 15. Then 1998, that's 18. And what else do we have? 99, 19, 20, and then we have 21, 22, 23, right?
Mm-hmm.
So we go here and we put the thousands in. Now, one thing you worry about, so I'm going to put 113, 176.7. Is it
28.8.
228.8? Then
261.4.
okay, 289.5.
Yeah.
Okay, and then 315.3 or 4.8?
315.8.
Three more, we got 346.6, is that right?
Yeah.
And then
357.5.
357.5, and then
367.
367. Now, one thing you can do when you have these numbers this size, that you can get away with not putting every decimal point there, and you'll still get pretty close to the same thing. And then you go to find the regression. It says perform a quadratic regression. You go to Stat Calc 5. You see that?
Mm-hmm.
And then you press calculate, and it gives you an equation here, gives you quadratic regression. So you get 4.49 x squared, or 0.449 x squared, just write it in hand, 0.934 x, and 114.7 for your y-intercept. Okay? And we come back to our function editor, and we have our plot 1 turned on. So 0.449 x squared plus 0.93 x plus 114.7. And when you graph this, you're going to see nothing, because the dimensions aren't set right. Even if you go to zoom 6, you're not going to see anything. Okay, what you can do is set your window. You look at your table, you say, okay, we'll go from 0 to 23, so I can set this 0 to 25 by 1s. Actually, I want to make that, I want to go maybe 0 to 30. And I'll show you why after a minute. Or 0 to 35, something like that. Thousands, okay, these are thousands, so I'm going to go for that 0 to, we want to know when they reach 450, so I'm going to make this 500. So we go to table view, go to window, 0, 30, and 0 to 500. And I guess I can go by tens, and then just see what happens. Okay, did you get something like that? Anybody have trouble getting something like this? Did you get this? Elizabeth, you got this here? Do you need help with something here? Are you transcribing? Okay. And then it's asking a question. Predict. We're going to predict when our patent applications will reach 450,000. So how do we use our prediction here? I want to show you something you can do. Now you can trace the function, you can trace the graph. I will show you something you can do that's pretty good. You can go here and mark 450,000 right here, and then graph. And then what can you do? You can trace, but you can go second, trace, 5, enter, enter, enter. And then you have, did you trace that and get about that anyway? Yeah. The problem with tracing is you're not going to get exactly on this because it'll advance incrementally. But, so what is our answer going to be? This is approximately when are we going to have 450,000 patent applications? Okay, 26.3, what is that going to be? Predict the year. What year is that going to be? What year is that? Yeah, 2006. 2006, right? It's 2003. So it's just going to be 3 more years. Now, so is this prediction going to be an interpolation or an extrapolation?
Yeah, what?
You weren't in class last, you weren't in Algebra 2 honors. You know that, interpolation or extrapolation? Elizabeth, do you remember that?
Correct.
Is this an interpolation or extrapolation?
Oh,
No, you don't remember?
I remember the term.
Yeah, you remember talking about, you remember, Karina, if this is interpolation or extrapolation? Okay, well, this is an extrapolation. Interpolation would be inside the data set. When you go outside the data set, we call that an extrapolation. So you're extending. And how confident are you of this extrapolation? I'm not super confident, because what does this look like here these last few years? It looks like it may be kind of peaking, right? But according to the way the problem is worded, and according to what they told us to use, this is the correct answer, okay? So just realize that we have their limitations, these types of techniques, especially when you extrapolate, because you're going outside, you're predicting into the future. Predicting the future is always an extrapolation, because it always has uncertainties. So that's that one. Actually, I want to go ahead. I want to leave that thousands up there. Okay. I want you to look at 66, which just play with that one a little bit. I will take attendance for you guys. Okay, find the slope of this section of highway. What is the slope of this section of highway?
$350.
3/50. Okay, slope equals 3/50. How did you get that?
For every, if you rise 6 feet, you are 100, so I just...
Yeah, so what it is, and they really pretty clearly delineate, right? So you had 6 feet per every 100 feet, 6 feet vertically for every 100 feet horizontally, which simplifies to 3/50ths. Another thing is they actually give you these numbers, so 6% could be another way of saying it. Another way of saying it is you can put .06, right? So there are different ways of saying it. So on a highway, we'll call this, that's the fractional way of doing it. Well, on a highway of 6% grade, what is horizontal distance required to climb 250 feet?
1,166.67 feet.
Okay, so you're applying this here. So you're saying that .06x is equal to 250. Is that how you did it? Then if you divide by .06, you should get it, right? So 250 divided by .06. So is that what you got there? Right, so right, okay. About 4,167 feet. And then a sign along the highway says 6% grade for the next 7 miles. Estimate how many feet of vertical change are there along those 7 miles. One thing is, oh yeah, they give us the units there. That was helpful. So what is that going to be? Times 7 times 5280. Doesn't that sound right? So 2,218 feet. Okay, so that's quite a bit of climbing. All right. Questions on this one? Okay, yes. Yeah, go ahead. The next one here, last one we'll look at is problem 67. And what I did for 67 is so we have this right here. The age and weights are recorded. Draw a scatter plot of the data. Find the linear regression model. Interpret the slope of the linear regression equation, and superimpose the regression line on the scatter plot. Okay, it's this one here. Is going to be right here. 29 will be right here. To 31. Yeah. And then 34, 34, 32 was about right. Here. 38, 34, here's 38, 34, and 43 is a little bit outside here, so it's be right over to the right. 43 would be 39, so way up here somewhere. So that's going to be a digit. When you graphed that in your calculator, did it look about like that?
Yeah.
Yeah. Okay. So calculator, stat, edit, and again, clear down. 1921. 27, 29, 31. 31. Next will be 34, 38, 43. So we have this, then the list here, we go to, looks like 22, let me read this, 22, 23, 25. Next we have 28, 28, 31, 28. And then three more. We got 32, 34, 39. If we set up our window 0 to 50, I think we can go by ones, and then here we'll go 0 to 50 too. We can go by ones, or we can go by 2 since my graph paper said 2. 2 graph. So that's what it looks like, right? And then stat calc what? 4. So we have this 0.68x plus 9. Should be something like this. Does that look like what you got for it? And it says interpret the slope we put y equals 0.68x plus 9. Interpret the slope of the linear regression model. What does the slope mean? What does our slope mean? 0.68 what? what is slope? What is a definition of slope?
M something,
Pardon me?
M something.
Okay, what it is, this is going to be weight, 0.68 pounds per month, right? So on average, these little baby girls are going to increase in weight 0.68 pounds per month on average. So that's the meaning of it. And you predict the weight of a 30, okay, we did the imposition of the line on the scatter plot. How do we predict the weight of a 30-month girl? You can go to, I think you can go to second trace in value. I think you can put x equals 30 right here. And it tells you, doesn't it? So 29.4 pounds. So 29.4 pounds. And you could do it manually too. You can put in 30 here and just calculate out 30. 30 storage x 0.68x plus 9. So there are different ways of doing that. Okay, that'd be part D. So really that's it. I want to go ahead and talk to you about the test you're going to have shortly, which is going to encompass what we've gone over before, plus it'll go over also inverses of functions and composition functions. So I want to do the composition first. So if f of x equals x squared and g of x equals 2 over x, what is f of g of 4? Okay, so we've got two functions, f of x and g of x, and then what is f of g of 4?
Wait,
I think I did it. I think I did it in my head. Okay. F of g of 4 should equal. Did you get one yet? What'd you get? Okay. Elizabeth got 1/4. Anybody else get that? Karina, you got it too? You did? Justin, did you get that? Okay, let's take a look at that. What you're going to do is plug in 4 for this. So g of 4 is going to be equal to 2 over 4, which equals 1/2. And then you want to find f of 1/2. So that's going to be 1/2 squared, which equals 1/4. So the thing is, you plug in your number into this thing right here first, find that, and then take that, plug it into this function, and then you'll get your answer. Yeah, 1/4 is the correct answer. Okay? And I wrote this down. This is in appearance pretty similar to one that'll be on your test. So would that be okay? You'd be able to do that?
Yeah.
Okay, good. Another thing you're going to have is if f of x and g of x are inverses of each other, and f of x equals x minus 2 over x, I'll say x plus 2 over x minus 4, what is g of x? And this is one of those that when you get to these things, I have trouble doing these in my head as much. I want you to be able to test these in your calculator too, because that's very helpful to figuring out what these are. Okay. Anybody come to, you got that, Elizabeth? Karina, you got that? How did you got it here? You got it? Okay, let's go ahead and look at this. What about Riley, did you get this? Let's rewrite this thing. Write this as y equals x plus 2 over x minus 4. And now we'll switch x and y, right? And now, if we multiply by y minus 4, we get x times y minus 4 equals y plus 2, and then xy minus 4x equals y plus 2. And then if we add 4x to both sides and subtract y from both sides, those will cancel, and we have left xy minus y equals 4x plus 2. And then if we factor out the y, we have y times x minus 1 equals 4x plus 2. Divide by x minus 1. We have y equals 4x plus 2 over x minus 1. And that would mean, that would be inverses, so it would be g of x, right? Is that what you got for that? Did I make any mistakes on that? No? Okay. Let's check it to be sure in our calculator, because what's going to happen on your test tomorrow, I think this could be a multiple choice test. So what we're going to do is take the 37, we do have some time, all right. So we go to this 4x plus 2 over x minus 1 and go to zoom 6. And so we're going to see if this one is the inverse of the original. We have x plus 2 over x minus 4. So we graph this one, and lastly, if we go ahead and set this y equals x, we should see a reflection. Do those look like reflections? Pretty close, especially if we go to zoom square. We're going to proportionalize it. Yeah, so these are inverses of each other, so that's a graphical demonstration of their inverses. So anyway, that's as far as there'll be a couple more things.